next one is the composition of patterns, and well, for that, I'm again using the design patterns, the Head First Design Patterns book, but I did this translation. So so at the end, we're going to put this on YouTube, but I think this video will be only relevant to people who know English and Turkish. Because I make the examples, in Turkish only to make it fun. So you remember that we had this, to start with, we started with the strategy design pattern, and we had different types of ducks, red-head duck, mallard duck, this is called green hat, yeşil başlı ördek. So all of them had the capability of quacking, so we have a quackability of the of all these ducks, and all of them has to be having this method in them, so everyone can make a different sound. So we started with this, and we had different things. This one has the same, but it is making a different sound. This one has, the same thing, but it is making a different sound. So we were able to modify this function, this methodology within, just like you remember that, just like any other attribute of the object, any other like integer, name, or string, floating point, we were able to now to change the methods in them. In the runtime, we can add and remove different functionality to our objects. And so we can, if we use this, we have this simulator. We have different ducks. We are calling them with its interface name, and we have their fixed. What was the name? Concrete classes. And when we say run, so this is calling the same method, but for all of them, for all different type of object or concrete class, we have a different sound coming from them. So, let's say that we have some geese around. So geese make a different sound. Well, other than that, because they are different, we have a different function for them. It's not vatla for them. It is honk. So I checked on several references. Geese are making really that kind of a sound. It's not. I cannot make it, but it's like a croak type of thing. It's strange. Anyway, but the method name is different. So we need another design pattern to be able to integrate it into our simulator, because we want to be using it with our simulator. We wanted to call this one under the same method name vatla. All right. So we need a new thing here. You know what it is? A new design pattern in order to make this, turn this into, this is using a different name, a different method name, but we want to be able to use this under same simulator with the same name, that the other method name, vatla method name, but this one is func. So we need what? Do you think?
Strategy.
No, we already, strategy that we're using, but we need another thing for that to be able to use that. We have something, we're changing it, using something else, like we have, I tell you what it is. It's easy, it's an adapter. We need an adapter to fit this one into our, because this one was, we had a simulator to use, to simulate these, try out these or test the duck family of classes, and we want to use the same simulator, but this time with the geese. With the geese, it is a different thing, so what we need is an adapter so that it will fit into this geese thing. So what we need is, we have the geese adapter, which is again a quackable thing. It is quacking, so it is using the same interface, but it is accepting, this geese adapter is accepting a geese. So we initialize it with a geese, and when you call it with the same name, because, well, since this is it's using this interface, it has to implement this method. But when you call this method, it is using this. Its own, so it is an adapter after all. And so because you have that, now you can instead of using the geese, the class, you immediately use the adapter, its adapter, instead of that. And it is again, since using the same interface, can be controlled with this interface, Vaklayavidir interface. All right, so there is no change. I can still use it. So this is, you know, the idea of using the adapter. So there are other requests coming. We want to be able to count the number of times that all of them are making the sound. Quack, quack, weak, whatever it is. We want to be able to count it, how many times that they are using it. So what do we need? We need something that, a counter, of course. And within this counter, whenever my class, my original duck class, is called with, you know, with this quacking sound, when this quacking sound is called, it will increase its internal count by 1. Okay? So, well, actually, this is a simple, very simple encapsulation. So what you need is a counter that will be counting things, but within it, it will keep a duck object. And that duck object, whenever I call the counter, and it is vakla command, it will first increase the counter by 1, and then we'll call the vakla command within itself. So this is a decorator, but it's a very simple decorator. So we don't have, as you remember, that we had a series of encapsulated objects within each other. You would remember with the coffee example. We had the base coffee, and when we were having all the condiments, we were calling them, and we had layers and layers of objects within each other. But with this one, only one. With this, in this case, there is only one layer, and that is that we have this duck. So it's itself using this interface, Vaklayavidir, but at the same time it has a duck inside it, under this very same interface. But in addition to that, we have a static integer to count number of quacks that it is making. All right. So when I start this up, I'm constructing it with a duck, and then whenever this one is called, I call this command, the very same command of this ördek vakla, and then I'm increasing this count by 1. So, well, whenever someone asks, I give the count number. All right. So when I try it with my simulator, this time, since I want to use it with the counter, with my counter, instead of using directly this concrete class, yeşil başlı ördek, I am giving this yeşil başlı ördek to vaklama sayacı. So now I have these things, and then when I use it, I can also get the count. I didn't write it up for this, the GEES adapter, the KAZ adapter, because I didn't, I don't have a decorator for that. That's something different. But I can also write a decorator for this too. For this, because this is something different, So, but we have a problem here. The problem is that we can have by mistake, I can come up with some ducks, that somebody can generate ducks without, he or she would forget to wrap it around a decorator, but I want to be able, I want to count all of them, all of the sounds that they are making. I don't want to miss any one of them. So in order to really be sure that all the ducks are counted, all the quacks of the ducks are counted and none of them has been missed, I have to be sure that this is happening. That I have a new vaklama sayacı and never directly a yeşil başlı ördek is being used. All of my variables of this kind is starting with this new vaklama sayacı, and I'm passing a concrete duck to the vaklama sayacı, and this is how I make sure that I'm counting all the quacks. And to do that, again, now I'm adding another design pattern. I use an abstract class. So for each one of them, I'm creating these type of objects with this abstract duck factory. Okay, so I keep it abstract because I have a duck factory which is giving me the ducks without any counter, and I have another duck factory which is countable ducks, the factory of the countable ducks. So this one is giving me all the kinds of different kinds of ducks with counters that I can count. So I'm now sure when I create something specifically, I can get either a duck with or without counting ability. All right. So what I did is I have a strategy pattern that I can differentiate, their quacking sounds. I have ducks. I maybe have different features of these ducks. I don't know, the color and the type, everything could be different. But also their sounds that I can differentiate, or maybe I can also differentiate their flying ability. I'm now differentiating their quacking ability, so they are quacking differently for all of them. And then I said I had a adapter to change a geese into a goose into a duck, and then I added a decorator to be able to count number of times that they are making the quack sound. So when I use the abstract factories within my simulator, instead that I have a factory and I'm asking that factory to create it, to create all of them. I don't have that yet for the goose. For the geese, I need a new factory because that's something different, right? Oh, that was the next slide. Good. I thought about that. So let's say that I have another request coming in. To be able to show you another design pattern, just to add this in. That I have flocks of ducks. That ducks are not incoming. They have families, so number of them. So when I ask them to quack, I'm not going to be asking each an individual to quack, but I want to give a quacking command, and all of the flock will be doing it at the same time. So that's the idea. So I want to be able to do this. I want to be able to give this command to a collection of them. All right. So here's what I do. I have a flock, sürü, which is again itself is quackable. Just like the duck itself, or just like the goose adapter itself, it is again quackable, quacklayabilir. And I have an array list of quackable things, whatever they are. Either they are red-head dogs or how do they call it? Mallard, or the other one that you use it in the bat. Rubber duck, yes, the rubber duck. So I can add them into this here, and then I can ask them to quack, and every one of them within this family, one by one, will be quacking. So I'm not going to be asking them to quack one by one, but when I call this flock, only this method, then it will do it itself. So, this is, and besides, as you can imagine, that I can add another sürü, another flock under this flock, because all this is accepting is a quackable thing, and sürü itself is a quackable thing, as you know, right? So I'm allowed to add another sürü, another flock under this flock, right? So this makes it what?
Is this decorator?
No, decorator we already used. What is this?
Composite.
That's a composite pattern. That is composite because now I'm able to have a tree structure that I'm able to put things that, a flock under a flock, another flock, I can have as many flocks that I want under the flocks. And yeah, so this is exactly what I'm doing. I'm adding these mallard ducks, 1, 2, 3, and I'm adding this mallard duck flock into my duck flock. So then I can have them, all of them, to quack, and I can then count number of times that they are quacking. Because the thing is, what happened is this: I'm getting these. I'm creating the flock not out of ducks itself. I'm making this flock out of all the. I can do this, You can imagine. I'm doing this with the decorator. I'm having decorators. Decorators means that I can count the number of quacks that these ducks can do, And this is the decorator, you would remember. So it is, I had this duck object inside a counter. So this is the decorator that I have. And I put all of them into a flock. So this is a flock. But all of them are still, all of them, yet the flock is as well, and this counter as well. They are all vatlayabilir, they are all quackable. So they are all using the same interface. They're all using the same interface. This decorator, as you know, decorators are using, they are wrapping an object. They are wrapping this object. This object is using an interface, which is a, in this case, it is a quackable or vatlayabilir. The decorator itself, the wrapping object itself, is the same interface. In the composite, the array that is, collecting all of the individual ducks, it is as well the same interface. So I can either put in this composite, either I can put the ducks, or either I can put the countable ducks. It doesn't matter. I can do all of them. Right? Does it make sense? Okay, so I forgot what this slide is about. It sometimes happens. Sometimes you admit it, just like I do. It is seldom the case. Nobody admits. But there are different ways to handle this situation. As I said, one, you admitted that you forgot what this slide is about. Number two, you would say something like, "Oh, this is not important," and then you can skip. Or number three, you try to remember without making it too obvious. Now I'm trying to do the last one. I'm trying to remember what this is without making it too obvious that I don't remember. Menu and menu item both had methods. Yes, in the previous example. However, duck does not have an add method in this example.
I guess it was composite pattern.
Yes, it is the composite pattern, very much. Oh yeah, the menu and menu component had the add method as the menu item. I really don't remember this.
Can it be iterator? Just ask.
Can it be what?
Iterator.
Iterator?
No, I don't think so.
No, it is nothing about that.
No, but I remember specifically the menu item example. But
Yeah, I do remember as well. At least that one I remember.
composite iterator, maybe.
No, it's nothing to do with the composite iterator. This is very much the root. No, what it says is yeah. You see, it was the reverse. In the menu component, in the menu example, we had this one and this one, sort of the same thing. Menu component and menu. But in this case, it is the menu item. It is the duck. It is not the float. It is the duck who is quackable. So that what makes, why it is making it different? Because it was the case. We use this as an abstract class. Actually, we did it in both ways. When we were doing it together with you, we did it as an interface. But the example that in the book was in the composite pattern. It was an abstract class. This was an abstract class, and some of them are being used. You remember that? And we were throwing exceptions. We were throwing exceptions within the whole methods in here. We're throwing exceptions, and if we were implementing some of them, we were having, we were overriding them, and for the ones that we were not overriding, exceptions were thrown. So it was safe, right? It was safer to use it this way, but in this example, because we are using the interface, like floats and ducks, that is not the case. So it is maybe not safe, right? So we can do whatever we want with this one. Try to, but because we were throwing exceptions in this one for the ones that were not supported. So that's a different case. So that's a different one. Does it make sense? No, it doesn't make sense. I know. I listened to myself and I said no. What am I talking about? Look. Let me show you. Sorry.
What show the difference between decorator and composite pattern?
No. This is the composite pattern applied in two different ways. So one way is this. No, rather this. The other way is yeah, I found it. That was the one. Menu items. Yeah, this is the one. Composite pattern, that was. So in this one, what we had, let me see. This is the menu component. So we have all of them had this exception thrown. This was the abstract class, and this was the menu component. So this is similar to our vaklayabilir. So it is sort of similar to that. And then we have the menu items. Menu items just plain, they don't do anything else, like they don't have remove, they don't have add. So when and if you call any of these within the menu item, they don't do that, but they are